Okay, let's balance 3 reactions together. So you see I've got 3 written up here, and you can just do them, we'll do them one at a time. You'll notice I really didn't give myself enough space to do the chart because I'm not going to do the chart. I'm going to just write the numbers in on the balanced equation. Please remember to only write in coefficients. I cannot change the subscripts. Remember, the subscripts are there to make sure that the charges in this add up together to be 0. Zinc is +2, chlorine's -1, so together I needed 2 chlorines to make that 0. So I cannot change these subscripts. All I can do is add coefficients in front of the compounds or elements. Also, I would highly recommend doing this with a pencil because you're probably going to be erasing some and then rewriting it. So just know that's part of the process. Okay, so right here we have HCl plus Zn makes ZnCl2 plus H2. Notice right here, H2, even though it's written by itself, H, I write a 2 because it's diatomic. That was talked about, I believe, in Module 4. You need to have those memorized, the 7 diatomic elements. Okay, so let's go back through my tips. Remember, I suggest picking 1 to start with and moving from there. I also suggest not starting with H or O. So probably in this case, I would start with Zn or Cl. And to me, when Zn, zinc, is by itself right here, that means it's going to be pretty easy to balance because there's nothing connected to it. So any changes I make to it just changes Zn. So I'm going to start with Zn. So I'm going to check. There's 1 Zn on this side, 1 zinc on this side. So I'm not going to write any numbers because those are balanced. Next, I'm going to go to chlorine. There's 1 Cl on this side. On this side, there's 2 Cls. Okay, well that's not balanced, so I need to go make this side have 2. I don't do that by writing a 2 here. I write the 2 in front. Okay, so I'm writing a 2 right there. I'll underline them as I do them so you can see where I'm writing. So now I've done zinc and chlorine. Now I'm going to do hydrogen, my final one. Well, I stuck a 2 here, so now there's 2 hydrogens because that 2 applies to the H and the Cl. So I have 2 hydrogens here. Let's look on this side. I have 2 hydrogens here, so this one is balanced. Okay, and it's always good if you want to go back and just double check at the very end. 1 zinc, 2 Cls, 2 Cls, 2 hydrogens, 2 hydrogens. I am balanced. I find that a lot easier than going through a whole chart for all of these, just to kind of go one at a time and work your way through. Okay, the second one takes into account polyatomic ions, which were those groups of atoms. They're one of those groups of atoms I was talking about in the first video where I said groups of atoms that appear together can be balanced together. So you learned and should have memorized your polyatomic ions in Module 5. And so here we're using them in a balanced equation. Okay, so this is NH4ClO3 plus Al2SO4, 3 outside the parentheses, makes AlClO3 with a 3 outside the parentheses, plus NH4, 2 of them, and SO4. Okay, hopefully you know all those names, but the names aren't necessarily important right now. What I want to point out here is notice how the groups stay together. Right here we have NH4. Over here we have NH4. The N and the H did not break apart from each other. They stayed as a group, NH4. Right here, SO4. Right here, SO4. Okay, they stayed as a group. So what that means is instead of trying to balance this as S and O, I can balance it as the SO4 group. All right, anything that stays together. So in all these cases, the ammonium, the NH4, the sulfate, the SO4, and the ClO3, both all stay together. So I can balance them as groups instead of having to balance them as individual atoms, which makes it a whole lot easier. So again, I'm going to start with pick 1. I tend to save the groups for last. Okay, I try to pick an element for first. So if you notice, this is a group, that's polyatomic ion, polyatomic ion, polyatomic ion. Really the only thing that's by itself is aluminum. So I'm going to start with aluminum because to me that's probably going to be the easiest. So right here, Al2, so I have 2 aluminums on that side, reactants. On the product side, I only have 1. So I'm going to write a 2 right here. Remember, I can't put a 2 subscript. That doesn't work. You have to put it in front. So there's my 2. Okay, now, let's see. I'll probably just start at the beginning and start with the NH4. Okay, since all the rest are groups of them. All right, so there's 1 NH4 here. There's 2 NH4s here. Okay, so I'm going to stick a 2 here to start with. All right, then I think I'll do the ClO3s. And hopefully some of you are starting to see. Let's look at ClO3. I've got 2 groups of ClO3 on this side. Hopefully you see that. There's 2 ClO3s. Over here I have 2 times 3 ClO3s. So that is 6 ClO3s to begin with. Okay, over here, because remember I stuck this 2. So this 2 applies to this group of this 3. So that makes 6 groups of ClO3 together. Okay, well, that means I need to change. So if this is 6 and that is 2, I need to make this one 6. So I'm going to go ahead and erase this 2. I'm going to put a 6 there. All right. Now, hopefully you see that just messed up my NH4s. You can do one of 2 things here. You can keep going, and then when you come back and start again, you'll fix your NH4s. Or if you notice your NH4 has now been messed up, you can go back to NH4 and do it again. So I'm going to go back. Now I have 6 NH4s. Over here I have 2 NH4s. So hopefully you notice if I put a 3 here, 3 times 2 is 6. Now I have 6 groups of NH4. Then the final thing I have is SO4. So on this side I have 3 SO4s. And on this side it looks like I just have 1, but remember I just put this 3. So the 3 applies to both groups. So I have 3 SO4s. So actually I am now balanced. Okay, and if you want, we can check it. You could always check. I have 6 NH4s on this side. 3 times 2 is 6 NH4s on this side. I have 6 ClO3s on this side. I have 2 times 3, which is 6 ClO3s on this side. I have 2 ALs, 2 ALs. I have 3 SO4s, and I have 3 SO4s. So I'm completely balanced on this one. This is one of the tougher ones, okay? If you need, fast rewind the video and watch me work through that again, because this is probably one of the tougher ones to balance because it includes so many polyatomic ions and because you have to go back and change some things as you work through. Okay, last one, C7H16 plus O2 makes CO2 plus H2O. So again, pick one to start with. I suggest doing H and O last. Specifically in this one, I suggest doing O very last because notice O appears 1, 2, 3 times. Okay, so anything that appears over 2 times is going to be your hardest to balance. So in this case, it's going to be oxygen. So let's start with C since we're saving H and O for last. So on this side, I have 7 C's. On this side, I only have 1. So I'm going to put a 7 right here. And again, I'm underlining mine just so you can see them on the whiteboard, the numbers I'm adding. You do not have to underline, you just have to have the 7 there. Okay, I would do H next because again, I'm saving O for last because it appears 3 times. So it's H16 in the reactants. Over here I have 2 H's, so I need to get them to 16. So I'm going to stick an 8 right here because 8 times 2 is 16. Now I have 16 on both sides. Now we're going to do the oxygens. Please pay attention to all the oxygens that exist in the problem. Okay, over here, there's 2 oxygens. Right here, there's 2 oxygens, but we have 7 of them, so 7 times 2 is 14. But please don't forget, we also have 1 oxygen here, which we're multiplying by 8. So I have 14 oxygens right here, and I have 8 times 1, which is 8 oxygens here. So that means total, all right, if I can do my math correctly, I believe I have 22 oxygens on this side. This is why it's a little harder when it appears in 2 places because you need to add them together for your total number of atoms. So I have 22, 14 plus 8. Okay, so I need to make O2 equal to 22. Hopefully you can see I put an 11 in front of it because 11 times 2 is 22. And if we want to go back, we can double check everything. 7 C's, 7 C's, 16 H's, 8 times 2 is 16. Now we do the O's. 11 times 2 is 22. 7 times 2 is 14, plus 8 times 1, which is 8. So 14 plus 8 is 22, so I am balanced. Again, you can always check.